Continuing with section 3. We start off with looking at what the z-score of a data value is. A z-score gives an exact location in terms of the standard deviations of a data value from the mean. Some examples. Example A, we plug the data value into the formula to find the z-score. We get z equals 1, which means the value 110 is exactly one standard deviation above the mean of 100. For B, again using the formula to find the z-score for the value 80, we get z equals negative 2 here, which means 80 is 2 standard deviations below the mean of 100. Another example. Here, we are given information from students in 2 different classes, and we want to know who scored higher. Let's start by finding the z-score for both students. This way, we know exactly how far above or below the mean each student scored. We find that exam 1 student has a z-score of 0.3, and exam 2 student has 0.5 z-score. So, from this, we can say that exam 2 student scored higher since they were above the mean more than exam 1 student. Percentiles are measures of location which divide a set of data into 100 groups with about 1% of the values in each group. The 50th percentile is the same as the median. Percentiles are not the same as percentages. They are a location of a data value. To find the percentile of a data value, we divide the number of values less than x by the total number of data values. An example. Following the percentile formula, we get 38, which means the data value 47 is the 38th percentile in the data set. For B, following the formula, we get that 54 is the 50th percentile. For C, following the percentile formula, we get that 65 is the 88th percentile of the data set. In the last example, we get that 41 is the 21st percentile of the set. Now we want to look at examples for finding a data value given its percentile. Below are some notations for the unknowns, n being total number of data values in the set. K being percentile used, example, 10th percentile means k equals 10. L is the location of the value, and P sub k is the percentile. L is always rounded up if not a whole number. And even if L is a whole number, we take the sum of that data and also the next data value and divide by 2. Some examples. For example A, we want the location of the 20th percentile. So following the locator formula, we get 4.8, which we always round up if not a whole number. So the location of the 20th percentile is 5. So the 20th percentile of the data set is 39 points. Example B, we want the location of the 80th percentile. Again, following the locator formula, we get 19.2, again rounding up to 20 since not a whole number. So the 20th data value is the 80th percentile, which is 61 points. Finding the 50th percentile, again following the locator formula, we get 12 as the location, which is a whole number, so we average that and the next value. And we get 53.5 points, which remember is also the median. Now we want to find where the 95th percentile is. Following the locator formula, we get 22.8, which we round to 23. Which means the location of the 95th percentile is the 23rd data value, which in this case, 69. Next, we look at quartiles, another measure of location, splitting a set of data into 4 groups with about 25% of the values in each group. Q1 is the 25th percentile, Q2 is the 50th percentile, and Q3 is the 75th percentile. So in example 5, we want to find quartile 1, quartile 2, and quartile 3. We start with quartile 1, which is just the 25th percentile. Which we get a location of 6, so we average that and the next value to get quartile 1. So we average the value 42 and 43 to get 42.5 as Q1. Quartile 2 is just the 50th percentile, which we also know is the median, which we already did, and we know is 53.5 points. Q3, or quartile 3, is the 75th percentile, so we find the location using the locator formula. We get 18, which is a whole number, so average that and the next value to get Q3. So we average 59 and 61 to get Q3, which is 60 points. Below are a few more statistics we may look at with quartiles and percentiles. Next, we look at the 5-number summary and box plots. A box plot is the graph of a data set that consists of a line extending from the minimum value to the maximum value and a box with lines drawn at the first quartile, the median, and the third quartile. This gives information about the distribution and spread of the data. Box plots are best used for comparing 2 or more data sets. So since we have gathered all the data necessary for our football points example, let's create a box plot. So recall our first, second, and third quartiles. Also note our minimum data value is 36, and our maximum data value is 75. We have the 5-number summary we need for the box plot. Now we just need to label those values on our number line and draw a box. Minimum, maximum values are already labeled. Now we just need to label Q1, Q2, and Q3. And done.